to Rosmaya Mukhtar YouTube channel. Hi everyone, welcome to my YouTube channel. I am Madam Rosmaya. So in today's video, we are going to continue to discuss on this topic, potentiometer part 3. So get ready. In the previous video, potentiometer part 1 and part 2, we have discussed how to use potentiometer to measure the e.m.f of a cell. Now in this video, we are going to discuss how potentiometer is used to measure the e.m.f of a thermocouple. What is adjustment can we make in this potentiometer? So let's say this is potentiometer with the length L, a wire length L, connected to the cell D. Then one end of the wire is connected to point X and another point Y is connected to the galvanometer and also to the slider. So we adjust the galvanometer so that it has null deflection, and then we get the reading of the length L1 here. Okay, so we put a resistor in the circuit here. Okay, let's name this resistor as R2. Okay, and the cell D here, let's say it has voltage or potential difference 2.0 volt. Okay, the cell D here has no internal resistance. R is negligible. Okay, let's say the length, the wire here has resistance R1. So R1 and R2 are arranged in series. Therefore, voltage across AB is calculated using the potential divider formula, which is equals to the ratio of R here is R1 divided by R1 plus R2 times the voltage across the voltage of the cell D here. So we use potential divider formula to calculate the voltage or potential difference across AB. Okay, then we connect to point XY at point A here, and then the slider and galvanometer here. So the potential difference across XY will be equals to the ratio of the length of the wire AB, okay, L1 per L, times voltage across AB. So the voltage across AB is the voltage here. So we substitute this voltage into the equation here. So this is how we calculate the voltage across XY if we put or we add a resistor here into the potentiometer circuit. So why do we need to put the R2, this resistor, into the circuit? So we are going to discuss next. One of the use of potentiometer is to measure the e.m.f of a thermocouple. But the thermocouple give the potential difference about only 5 millivolts. So it's very small. Okay. So that is why when we going to measure the potential difference of the thermocouple here, so the value of X potential difference between XY here will be very small. Okay, let's say we do the calculation here. We do backward. Okay, where we are going to determine what is the length measured here, the balance length measured here when the galvanometer here is a null deflection. If the voltage across XY is 5 millivolts. Okay, now let's say we use the cell potential difference here is 2.0 volt. Okay, so without the resistor added here, okay, we are going to determine the length, balance length along the wire here. Okay, so we use the formula of potential divider So voltage across XY here will be equals to the balance length. We get L1 per L times the cell D voltage. So we substitute the voltage across XY for the thermocouple here, which is 5 millivolts, about 5 millivolts, so 0.05. And then L1 is what we are going to calculate. Then divided by the length of the wire here is 100 centimeter if we use ruler. And then times the cell D voltage here, 2 volt. Okay, so we cross multiply. So we get L1 only 0.25 centimeter. It's very, very, very small. 0.25 centimeter compared to the length of the wire here, 100 centimeter. So this value is too small. So therefore, the percentage error is rather high. So hence, the measurement of the e.m.f. would not be accurate. So that is why the reason where we must put the resistor here, okay, so that the balance length can be made longer, okay, so that the balance length can lies in between the 35 centimeter mark to 65 centimeter mark on the ruler. To increase the accuracy of our measurement, L1 must be large. This value L1 must be large. So to make it larger in value, so we need to add the resistor here. So we are going to determine how much the resistor here, the amount of the resistor here, so that L1 is large enough, which it can be lies in between 35 mark to 65 mark. So we use the calculation that we have derived just now. So let's say the length of the wire here has resistance 5 ohm. Okay, has resistance 5 ohm. So using the same cell voltage 2.0 volt. Here the voltage across XY here also we use 5 millivolt. So using the formula of voltage across XY here, okay, which is equals to L1 per L times voltage across AB. Okay, AB is voltage across the wire here on the ruler, and the voltage across AB, okay, is equals to the ratio of R1 to R1 plus R2. R1 is the resistance of the wire AB, okay, times the voltage cell here, 2 volt. Okay, so we substitute the values. Vxy is 0.05. Okay, and then R1 is 5. 5 divided by 5 plus R. So this R is what we are going to determine. Okay, the suitable values to be put here, so that the length L1 here is larger than 0.25 centimeter. So the ratio here, let's say we write it as 1 to make 0.25 just now measured is too small. So to make it larger, so we can use approximate value. Okay, approximate value is about 1. Okay, so the ratio of L1 per L, we increase the L1 so that L1 per L1 is about 1. Okay, so we substitute 1 into here. Then we solve for R. So we get cross multiply. Okay, so we get 5 plus R equals to 5 times 2 divided by 0.05. Then R we get 1995 ohm. So the value of resistance to be put here is around this value, 1995 ohm. So that we can increase the value of L1 so that it can lie, okay, in between 35 marks to 65 mark. So we can make adjustment to the resistance value here around this value. So to measure the e.m.f. of a thermocouple, okay, so the adjustment that we can make to the potentiometer here is to put the resistor here. So we can calculate the suitable value of R so that we can measure the voltage across XY here. and we can increase the value of L1 so that it can lies in between 35 marks to 65 marks, and we can get the more accurate value of the EMF. Okay, so that's all for our discussion, okay, in this video. Thank you for watching.